A vast region of the Pacific Ocean is warming at extraordinary speed, and the consequences may soon be felt thousands of kilometers away. El Niño has returned in 2026, but this is not developing like an ordinary event. Ocean temperatures across the central and eastern tropical Pacific have risen rapidly. Major forecasting systems expect further intensification, and the latest projections suggest this El Niño could rank among the strongest observed in the modern record. El Niño begins in the tropical Pacific, but it can reorganize weather across much of the planet. It changes where tropical storms form, shifts major rain belts, alters monsoons, disrupts fisheries, and influences temperatures far beyond the ocean where it starts. It does not create every drought, flood, heat wave, or wildfire, but it changes the background conditions, making certain extremes more likely in some regions and less likely in others. The story begins along the equator, where trade winds normally blow from east to west. These winds push warm surface water toward Indonesia and Australia. Near the western Pacific, the accumulated warm water fuels clouds and heavy tropical rain. Farther east, near the coast of South America, colder water rises from the deep ocean to replace the surface water being pushed away. This upwelling supplies nutrients that support plankton, fish, seabirds, and some of the world's most productive fisheries. During El Niño, that system weakens. The trade winds slow or sometimes reverse. Warm water that was concentrated in the western Pacific spreads eastward. Upwelling near South America becomes weaker, and the central and eastern Pacific grow much warmer than normal. Tropical rainfall follows the warm water, shifting storms away from their usual locations and disrupting atmospheric circulation around the globe. Earlier in 2026, the Pacific was only beginning to emerge from cooler La Niña conditions. Forecasts initially showed considerable uncertainty about what would happen next, but the transition accelerated. By June, NOAA officially confirmed that El Niño conditions had developed and were expected to strengthen. During July, measurements showed the important Niño 3.4 region continuing to warm rapidly. The Niño 3.4 region is a large section of the equatorial Pacific that scientists use to monitor El Niño. Its temperature is compared with the long-term seasonal average. An anomaly of at least 0.5 degrees Celsius, sustained alongside changes in the atmosphere, is associated with an El Niño event. Strong events reach much higher values. By the middle of July 2026, weekly estimates indicated that this region was already around 2 degrees Celsius above normal. That is an unusually high level for this stage of development. The event may not reach its maximum strength until late in the year, meaning the Pacific could continue warming for several more months. NOAA's July outlook gave El Niño a 97% chance of continuing into early spring 2027 in the Northern Hemisphere. It also estimated an 81% probability that the event would reach the very strong category during the final months of 2026. Being classified as very strong does not automatically mean every expected impact will occur. No two El Niño events are identical. The exact location of the warmest water matters, as do conditions in the Atlantic, Indian Ocean, Arctic, and atmosphere. Local weather can still interrupt broad patterns. However, stronger events generally exert more influence on global circulation, increasing the likelihood that recognizable El Niño effects will emerge. One of the first visible consequences often appears in the ocean near South America. When cold, nutrient-rich water stops rising efficiently, the food web can weaken. Plankton production declines, fish move into cooler waters or descend deeper, and animals that depend on those fish must follow them. During powerful past events, seabirds and marine mammals have struggled to find food, while fishing communities have experienced major reductions in their catches. Signs of disruption have already appeared in parts of the eastern Pacific. Changing ocean conditions have affected the distribution of fish, leaving some predators searching closer to towns and beaches for food. These events illustrate how a change in water temperature can travel through an ecosystem. The warm water does not simply make animals uncomfortable. It can interrupt the movement of nutrients that supports the entire marine food chain. On land, the impacts vary dramatically by region. El Niño commonly increases the likelihood of wetter conditions across parts of the central and eastern Pacific and portions of the Americas. Heavy rain can provide relief after drought, but when it arrives rapidly, it may also produce floods, landslides, damaged crops, and overwhelmed drainage systems. Across Australia, parts of Southeast Asia, the Indian subcontinent, and some other tropical regions, El Niño can favor drier conditions. Rainfall forecasts for July through September 2026 already show patterns consistent with a strengthening event, including an increased chance of below-normal rainfall in much of Australia and parts of the tropical Indian Ocean region. Dry vegetation combined with extreme heat can raise the danger of wildfires later in the season. El Niño also influences tropical cyclones, although its effects differ between ocean basins. Increased wind shear over parts of the Atlantic can disrupt developing hurricanes, sometimes reducing Atlantic activity. At the same time, warmer water and more favorable atmospheric conditions can increase cyclone activity in the central and eastern Pacific. These relationships are not absolute, but they change the probabilities that shape each storm season. The timing of this event is especially important because the wider ocean is already extremely warm. In June 2026, the average sea surface temperature across the ice-free ocean outside the polar regions was the highest ever recorded for that month. El Niño is now adding another major source of heat to a climate system that was already operating near record levels. The ocean has absorbed most of the excess heat trapped by human-produced greenhouse gases. This has slowed the rise of atmospheric temperatures, but it has also created marine heat waves, damaged coral reefs, raised sea levels through thermal expansion, and supplied additional energy to extreme rainfall and powerful storms. When El Niño releases part of the tropical Pacific's stored heat into the atmosphere, global temperatures often rise several months later. That delay means the most significant global temperature effect may not arrive until 2027. Previous major El Niño events contributed to record hot years after they reached full strength. Scientists cannot yet say exactly where 2027 will rank because global temperature depends on many factors. But a very strong El Niño developing over an already hot ocean would increase the possibility of new records. This does not mean El Niño is responsible for long-term climate change. El Niño is a natural cycle that has existed for thousands of years. It redistributes heat between the ocean and atmosphere but does not continuously add new energy to the Earth system. Human greenhouse gas emissions are responsible for the persistent warming trend underneath these natural fluctuations. The interaction between the two is what makes the current event concerning. El Niño temporarily pushes global temperatures upward, while climate change has raised the starting point. A weather pattern that once occurred in a cooler world is now unfolding in warmer oceans and a warmer atmosphere. This can intensify heat stress, increase the atmosphere's capacity to hold moisture, and make some rainfall extremes more severe. There is also uncertainty. Forecast models have improved significantly, but predicting the final strength of El Niño remains difficult. The ocean and atmosphere constantly influence each other. A burst of western winds can send warm water eastward and strengthen the event. A change in trade winds can slow its growth. The location and depth of warm water beneath the surface also determine how much additional warming can reach the top of the ocean. Some forecasts now place the likely peak near or above the strongest values observed in recent decades. Others show a wider range of possibilities. Scientists therefore avoid treating the most extreme projection as guaranteed. The correct message is not that the strongest El Niño in history has already been confirmed. It is that the event is strengthening unusually quickly. The probability of a very strong outcome is high, and governments should prepare for a broad range of impacts. Preparation cannot stop El Niño, but it can reduce the damage. Farmers can adjust planting decisions when seasonal rainfall forecasts show elevated drought risk. Reservoir managers can prepare for unusually wet or dry conditions. Health systems can plan for heat-related illness and diseases that spread more easily after flooding. Fisheries can monitor shifting fish populations, while emergency agencies can strengthen plans for fires, storms, floods, and landslides. Forecasts are most useful when they are interpreted locally. El Niño changes global probabilities, not individual daily weather events. One region may experience the classic pattern while another does not. A predicted dry season may still contain destructive storms. A wetter-than-normal season may include long periods without rain. National weather agencies therefore combine global El Niño outlooks with regional observations and shorter-term forecasts. Over the coming months, scientists will watch the Pacific for several signals. They will track the Niño 3.4 temperature, measure the depth of warm water below the surface, monitor trade winds, and observe where tropical thunderstorms are developing. Together, these measurements will reveal whether the ocean and atmosphere are becoming more strongly connected, a necessary condition for El Niño to reach its highest categories. The 2026 event is still developing, but it has already crossed a critical threshold. What began as a possibility earlier in the year has become an established and rapidly strengthening El Niño. The Pacific is warming, rainfall patterns are shifting, and forecasting systems increasingly agree that the event will remain powerful through the end of the year. The next chapter will not be written in the Pacific alone. It may appear in empty fishing grounds, flooded roads, weakened monsoons, burning forests, displaced wildlife, and new temperature records. A band of warm water along Earth's equator is beginning to reorganize the atmosphere above it. By the time the event reaches its peak, much of the planet may be feeling the consequences.